And hello, welcome back to this video on Blasius boundary layer equations. Just want to make some correction to the last video, and I'll leave it in the LaTeX document. The way to obtain f of eta, okay, f of eta, I don't think it's very wise to go by this chain rule method. Okay, the better way is just to substitute this expression for psi star into d psi star dy as follows. Okay, this will be a little bit iffy in my opinion. Yeah, iffy to prove. Okay, but somehow the maths kind of works out. But I think this way is more convincing, so I added in this correction. So you substitute psi star into del psi star del y star, and then you'll get this. And x star and Reynolds number, they should be constant with respect to y star. Okay, so you keep everything else constant. This is a partial derivative anyway. Okay, so once and then of course you assume Reynolds number is constant to both with respect to both x and y, because it's of the order of magnitude of 1 throughout the whole fluid. This is the y Reynolds number, which should not change very much because we assume creeping flow all throughout. It doesn't change. Alright, so they should not change with y star. Okay, so we bring x star out and we bring the Reynolds number out, and of course then we do our chain rule magic, and then we get f prime at the back, which is del by del eta of f, which is f prime. Okay, so more or less the maths works out to be the same. And the substitutions still work out to be the same, but just want to make sure that you know that this is the better way of getting del psi star del y star, and then you change it to this dimensionless stream function thing. I mean, both of them are kind of functions of dimensionless stream function, but f eta is more important. Okay, so that's how we do it, and the substitution, everything else should remain the same. Now that we've started dealing with del psi star del y star, we want to deal with the higher order derivatives, del 2 psi star del y star square, and the third order derivative, which I don't want to waste all that breath pronouncing. Okay, so before we begin, we want to start with higher order derivatives. So I just write down this premise. Okay, when we do higher order derivatives, just want you to note something. When we have del by del y star of this eta over y, okay, which is when you have del by del y star of eta over y, you get this quotient rule, right? You get the constant up, and then you differentiate the top with respect to y star, and then you get the bottom up, and then you differentiate the top minus top constant, which is eta, differentiate bottom, del y star, which is just 1, and divide by y star square. Okay, that's where we start. Why am I doing this? I'll show you in a while. Okay, so we'll just finish up this derivative first, and when we note that, okay, fraction, of course, we did earlier, right? Remember we did earlier, del eta del y star is just eta over y star. This is very convenient. So I'm just gonna copy all of this over. That's what we already proved earlier. What we have proven earlier. So you will see that this thing nicely actually cancels out very nicely. Alright, so I'm going to substitute this in here, and that will help to make life easier, as you'll see in a while. Eta over y star. Alright, it's eta over y star, and this partial y will just reduce to 1, So this, you'll see that these two terms actually will cancel out. You can see eta minus eta will be on top. Whatever's at the bottom doesn't matter. It will just reduce to 0. What does that tell us? Okay. Eta, okay, eta over y star is constant with respect to y star. Now this is very, very, very important. We can use this fact later on. Okay, so hopefully this proof has sort of convinced you so that we can start doing our higher order derivative terms. Why is this important? Because once you start doing higher order derivatives, for example, partial y star of f prime. This is the first example. Then you want to swap around the derivative terms, right? You'll need to do your chain rule thing, and of course you can do this. So you want to partial eta partial y star, and that's no problem. Partial eta partial y star, then you will have f double prime there, which is of course the eta derivative, right? And then you will just get eta over y star times f prime, f double prime. Okay, I'm skipping some steps here because you will get del by del eta of this f double prime. Okay, so that's the second one. Okay, this one will reduce to that. The third one will be here. Then we have, okay, del 2 by del y square, y star square, excuse me, y star square of f prime. Now this one, now we have a partial derivative term, second order derivative term. It's going to cause a little bit of problem, so to speak, because now we have to do this chain rule thing twice. So we will have partial by partial eta. Okay, let's see whether I have any. Yeah, never mind. This bit here. So we'll have to substitute the inside first, and then we'll substitute the outside. Okay. So what's that look like? Okay. Partial eta partial y star. That's one. And then we will have partial, okay, partial eta of f prime. Let's see whether this checks out. I'm not sure how this will look like in LaTeX. Now hopefully it, yes, okay, I have so many brackets. Okay, too many brackets. Alright, there's a bit of an overkill there, but okay, now you see this thing. Now if you were to differentiate both of them, of course this actually reduces to f double prime here. So let me just write that down. Of course that reduces to f double prime. But as you can see, once we start to differentiate things over here, yeah, we already proved here that yeah, when we swap things around, it should be okay. Yeah, we just now proved that when we swapped around the variables, and we could pull this this Reynolds number out, this Reynolds number over 2 out. It should be a constant. Now, you see, when we have this kind of a thing, we are supposed to differentiate this del eta, del y star, and then f double prime. Now, this proving that eta over y star, okay, which is del eta del y, okay, del eta del y, we just now proved it, yeah, over here. This is actually constant with respect to y star. What does that mean? We can just pull this thing out, and then we just substitute it again. Okay, so we'll just pull this thing out. We'll just pull out because it's a constant, right? This thing is a constant with respect to y star. We can just pull it out, and that makes it very convenient for us. Okay, so eta or y star, and this time I'm just going to skip some steps, and I'll just put square, because this thing also needs a change of variables. Okay, eta f double prime okay, so there you go, and that will give you eta squared over y star squared f triple prime. Alright, anyway, sorry for the hope you don't mind the mistake earlier. Hope it doesn't confuse you too much, but yeah, everything remains the same, and of course our substitutions here will be the same. So now we can actually just substitute these expressions back here. Let's substitute our expressions back. Okay. So this become, yeah. Let's substitute our expressions back. And I'll just paste 2 of these equations. Then this one will go into the last one. Okay, that's 1. And of course we'll have our second order derivative, which is, okay, did I replaced the wrong one, eh? Did I replace the wrong one? Okay, this one should be a third order derivative, triple prime here, and this should be, let's say, n eta, not n, it does look like n, doesn't it? Eta over y star times f double prime. So that is this thing here. So now we have changed almost all our psi stars into f. Okay, now that's I think we are halfway there. Now for the slightly more challenging bit, we have del by del x star into f prime. Okay, now let's deal with the x star terms. Hopefully it all turns out well. Okay, x star terms. Okay, so we'll need to apply the chain rule to this thing over here as well as this. So let's do a chain rule. Okay, partial x star, and that will equals to what? We will need eta at the bottom. Okay, and partial eta partial x star, like so. Hopefully this turns out well. Let's go. Let's see. Yes, okay. So now we need to evaluate this delta partial eta partial x star, which is going to be a little bit more challenging, but with chain rule shouldn't be too much of an issue. So let's go back up and let's see eta. So let's look for expression of eta, which is here. Okay, so I'm just going to quickly differentiate both sides by x star. And I'll again skip a few steps. Okay, I'll skip a few steps and just give you sort of the idea, okay? So we'll just differentiate the square root thing. Like so. I'm running through it very quickly. At least for my pace, yeah. My so-called teaching pace, yeah. So this part will become half RE, and then you have sort of a minus x cubed over here. So let me just write that down. Okay. So I'm just taking this out and I'm just writing this down, which you have fraction minus 1 over 2 x star. Okay, so yeah, I will just kind of skip steps. This is just a differentiation bit. And what happens? This whole thing you'll notice is just still eta. So let's just write eta over times okay, minus 2x star. Okay, there we go. So now you have a bit of negative signs in, it gets a little more complex. Alright, but thing is we can put this back on top, and that should enable us to replace at least this term. Right, so and also of course we can substitute these derivatives out too. And you'll see some terms getting a little bit messy, but you'll have to like live with it. Alright, so this one over here, this del by del x star will disappear, and we'll just put this in, and we'll just change it into f double prime. So that's changing the thing. Alright, so we're almost there. There's a little bit of 2 here, and these sort of things are present. Okay, next we will have this psi star that we need to deal with. So how do we deal with the psi star? We will again use the same trick. Well, it's not really a trick, it's just the definition. Psi star equals to f eta square root of x star times RA delta. So that will be this thing that we need to substitute, and unfortunately that is actually dependent on x star, so I'm not going to change out the derivative just yet, because it's a little bit more convenient here to just differentiate this expression with respect to x, so we can just substitute this in. You don't want to do extra work. Okay, so let's differentiate x this with respect to x on both sides, and you realize we'll need to apply chain rule again, or product rule. Sorry, product rule. Because now some terms are actually dependent on x. Alright, so we'll need to do product rule. Let's do product rule here. So we can factorize out the square root RE of delta. We assume that is constant throughout. And we'll just give some brackets. Okay. Yeah, we assume RA delta is constant. Okay, so now let's do product rule. Okay, so I'm just going to copy and paste. Yeah. Okay, I can copy and paste this. Okay, so I'm going to plus. I'll bring f eta out and square root of x out. Alright, so this is our product rule. So you see there's a f actually pops out here, and this term, I mean these terms here, we can use the same substitution as before. This term here, okay, so we need to have 1 over square root x. So we'll differentiate it straight away. That is just half, okay, half. Okay, and then 1 over square root x. Okay, so just put square root x at the bottom, x star. And using the earlier substitution, which was this substitution here. Okay, we'll just use this substitution and I'll say eta over 2x star will be this bit over here, because that's what we substituted before, remember? This is del f prime, del x star. Oh, this is del f, del x star. Okay. But yeah, I mean, the idea is the same, but instead of f double prime, you just get f prime. So we use this chain rule again, and we do the same not so magical magic. So okay, so we have f prime. I'm gonna take the eta out, and I'll just have eta over minus 2x star, eta or minus eta over 2x star, and that will be our product rule. And that's going to be it for now. I'm not going to continue too much anymore. Alright, but you can see in terms of f and x star, this is what it does look like. Okay, a little bit messy, a little bit complicated, but other than that, it is what it is. Okay, anything else I need to do? Not at the moment. I'll talk more about this in the next video. So I'll stop for now. Suffice to say, we're going to substitute this into here, into our del psi del x, or over here. It's even better. So I'll just do it now, right? Yeah, I'll just do it now, and then I'll say, okay, in the next video, let's deal with this messy term. Yeah, substitute wholesale. Nice thing about LaTeX or Word documents or whatever, you can just copy and paste. Alright, so you see we just substituted this rather messy term here, and hopefully some of the terms cancel out. And I think some of them will start to cancel out. As you can see, you may or may not see, I don't know, do you see? The f prime terms may cancel out, so it's here and here. Hopefully they do. Alright, but let's whether it actually does, let's check it out in the next video. So I'll see you again. Thanks for watching, and goodbye.